This video is a continuation of section 2.4 on linear functions. So previously we were graphing equations based upon which form they were in. Alright, and now we're going to look at something called slope, which most of you have probably heard of. But slope, whenever you see this letter M, that's how we know it's referring to slope. And the slope is found by subtracting the y coordinates over the x coordinates. So there are a couple of ways you can find slope, and one of them is if you have 2 points that are on a line, you can find the difference in the y values over the difference in the x values. This is also referred to as the change in y over the change in x. You may also have heard it referred to as rise over run. Okay, so we're going to look at a couple of ways you can find slope based upon what type of information you're given. Now, if you have a vertical line, its slope is always undefined. And if you have a horizontal line, its slope is always 0. And we're going to look and see when those occur. Alright, so if I'm asked to find the slope of a line, and I'm given 2 points, then I can use this slope formula here. And so it says subtract the y's over subtracting the x's. So this is a ratio. Alright, now it doesn't matter which one you call y sub 2 and which one you call y sub 1, as long as whichever one you say is y2, its x value is also x2. So I'll show you how it works no matter which way you choose it. So here are my y values, 8 and -3. If I set it up, I can say 8 minus -3. Alright, and because this 8 came first on top, its y value has to come first on bottom. So here are my x values. So I'll say -4 minus 2. And then 8 minus -3 is 11, and -4 minus 2 is -6, giving me a slope of -11/6. Now, like I said, it doesn't matter which y comes first as long as its x comes first. So if I work it out the other way, where I put -3 first, I'll say -3 minus 8, and then 2 minus -4 give me -11/6. And so these two things are the same, -11/6 and -11/6. Just make sure y's are on top and you're subtracting. Alright, and whichever y you use first, its x has to come first on the bottom. Alright, let's take a look at these next two. Alright, so I want to find the slope of the line that passes through these 2 points. I need to use the slope formula to do that. I'm going to take my y's, subtract them. I'm going to say -4 minus 7. And then on the bottom, I'm going to say 2 minus 2. I'll get -11/0. Alright, now notice here, alright, 0's on the bottom, and we can't have that. We say when that occurs that the slope would be undefined. So anytime you get 0 in the bottom, in the denominator, the slope is undefined. Now if you look at the points, alright, notice that the x values are the same. And remember, we talked about this in the previous video, that when the x values are all the same, okay, that it would look something like this. This was from the previous video. When x equaled -3, x was always -3 and y could be whatever. And this resulted in a vertical line. Alright, then remember we said here the slope of a vertical line is undefined. Alright, and you can see that occur here. Okay, so if it's an undefined slope, then we know it's a vertical line, and we can write its equation, alright, by simply saying x equals 2. Alright, so when it says x equals a number, we know that's a vertical line. We now know that its slope is undefined. So be able to relate those things from either direction. Given the equation, know the slope. From the slope, be able to know that it's a vertical line, and if you have any point on that line, you would be able to write the equation. Okay, let's take a look at the next one. The slope here would be Here are my y's. So -3 minus -3. And then my x's, -2 minus 5. That would be -3 plus 3 and -7, which gives me 0 over 7, which gives me a slope of 0. Alright, now recall when we first started, we said that the slope of a horizontal line is 0. So when you get a slope of 0, then you should say this is a horizontal line, and we can see that the y values are the same in this one. And so if we continue to list points, it wouldn't matter what the x value was, the y value was going to be -3. And remember, we talked about that in the previous video. Here, when we said y equals some number, is the horizontal line. All the y values are the same. Doesn't matter what the x value is. Alright, so down here, we know that we could write the equation as y equals -3. Okay, so this, that should be intercept, so put you an R there. Alright, this is just an additional way to graph a linear equation. So we've looked at picking points and plotting them. So we pick values for x, filled it in, and solve for y to get enough solutions to graph the equation. We have looked at graphing it when it was in standard form using the x and y intercept. Alright, and then now we're going to look at it. Let me see if I can get it to focus here. Another way that you can graph the equation. Alright, and if the equation is written in slope-intercept form, this is just a second way that you can graph the equation using some information. Alright, so slope-intercept form says y equals mx plus b. And now we are accustomed to seeing this because remember we had y equals ax plus b. And we picked a value for x, filled it in, and solved for y. Okay, these two things are no different. Now we just know that that number a and m are the same, and m, we said, represents the slope. Okay, so anytime you have a linear equation written in this form, y equals mx plus b. M and b are numbers, just like a and b are numbers. The number in front of the x is going to be my slope. And then the b is going to be my y-intercept. Alright, so what I can do is take these two pieces of information, the y-intercept and the slope, and graph my equation. Alright, so let's take a look at this one. Alright, from this equation, the slope is -4. And from this equation, here at the end, the y-intercept would be -3. So this is where my equation is going to cross the y-axis. So I'm going to go and mark that point first. So on my y-axis, I'm going to go down 3. Alright, now I can use the slope to get to all the other points that are on this line. And so the slope, remember we talked about it being rise over run. So the top number tells me how far up or down I can move, and then the bottom number tells me how far left or right I can move. And that is the ratio between each solution for that equation, or how I get from one solution to the next. The change in y over the change in x. Alright, so our slope for this one is -4. So notice it doesn't have, or we can't see at this moment, the run. It just has a rise. But remember, if anytime you have a whole number, it's understood to have that 1 under it. Alright, remember that -4 over 1 is the same as 4 over -1. Alright, these two values are equal. So I can use the slope to say I want to go down 4, right 1. So if I did that from this point here, I would go down 4, 1, 2, 3, 4, and then move right 1 to get to the next point. Alright, and if my paper permitted it, if space permitted, I could continue going down 4, right 1, down 4, right 1, finding all the points that are on my line. Alright, I can also do the same thing here, except I will go up 4 and left 1. So from my y-intercept, I'm going to go up 4 and left 1. And I can continue doing that. Alright, until I run out of space. And you should see how these coordinates, these points, begin to form a straight line. And you can connect them. Alright, remember making sure to go all the way through. Arrows on each end. Alright, and if you were to make a table, you would see that these points would fall in that table. Okay, let's look at this one. I have a line that's passing through the point -1, 5 and has a slope of -5/3. So they're telling me that my line is passing through this certain point. So I'm going to go, I know that this is a solution or a coordinate within my equation, whatever it may be. I know my line is passing through it, so I'm going to go ahead and put my dot there. So from the origin, I'm going to go left 1 and up 5. Alright, then from this point, I can use the slope to get to all my other points. So I can either go left 5, sorry, yes, I can go down 5, right 3, or I can go up 5 and left 3. Alright, so from this point, we're going to go down 5 and right 3. 1, 2, 3. And we can continue to go down 5 and right 3. Alright, and if space permitted, we could go up 5 and left 3. So it just depends on where the point falls that your line is passing through, whether it be the y-intercept or some given point, on which direction you go. So it's going to be really how much space do you have. And you can go both directions if space allows. Make sure you connect the dots to graph our equation.